Hi everyone, welcome to Data Precision with Shino, and we're doing a Google Developer Code Lab on connecting and visualizing our data in Data Studio. So Data Studio was initially called Looker Studio, but let us see what is Data Studio. So Data Studio, which was formerly called Looker Studio by Google, is a free web-based data visualization tool that turns raw information into custom reports, interactive dashboard, and charts. Now, Data Studio lets you build live interactive dashboards with beautiful data visualizations for free. Fetch your data from a variety of sources and create unlimited reports in Data Studio with full editing and sharing capabilities. The following screenshot is an example of Data Studio dashboard. So this in front of us is an example of a Data Studio dashboard. You can see the title at the top. You can see the single digit KPIs. You can see conversion rate. You can see cost per click. You can see top 10 campaigns. You can see device breakdown as donut chart. This is a table chart. These are line charts. And there is the date that the data set covers. Now, we're going to talk about community connectors. So, community connector is a feature for Data Studio that lets you use AppScript. So, let us look at what are community connectors documentation. So Data Studio community connectors enable direct connections from Data Studio to any internet accessible data source. So you can develop and use community connectors to create reports and dashboard with data from sources such as platforms for social media, CRM, which is customer and relationship management, search, finance, HR, public and open data sets, private company data, and any other data source or service that can be accessed using the internet over the internet using AppScript. So here they've explained how community connectors work. Now let us look at AppScripts by Google. We'll come back here for the practical part of it. Now, we can use community connectors in different use cases, just like I said earlier, for visualizing data from a commercial platform, for visualizing on-premise enterprise data, providing a way for our customers to visualize their data across our service, for creating a push button reporting platform, and for visualizing our own data from a web source, either creating our Google Fit dashboard. Now, for this code lab, what we'll learn how a data studio community connector works, how to use Google App Scripts to build a community connector, how to use community connectors in Data Studio. What we'll need is access to the internet, a web browser, a Google account, and familiarity with basic JavaScript and web APIs. We will now come and click on the blue next button in our lower right. So I had started this a bit earlier, a few minutes ago. So here is a quick survey. Why did you choose this code lab? So I selected under the options, selected I want to learn more about Data Studio. How do you plan to use this code lab or tutorial? I want to read it and complete the exercises was the selection I made. How would you rate your familiarity with Data Studio? I know what it is, but I don't use it. So that's my own familiarity level. What best describe your background? So my background is a business, financial, data analyst. So let us move on to the next page by clicking the next button. Now, here's an overview of community connectors. Data Studio community connectors enable direct connections from Data Studio to any internet accessible data source. So if we come here, you can see, let's look at the community connectors. So remember, we have connectors on any data visualization tool that connects to data. So here was where we talked about the connectors and how they work. So let's go back here. Data Studio community connectors enable direct connections from Data Studio to any internet accessible data source. You can connect to commercial platforms, public data sets, or your own on-premise private data. Community connectors can fetch data through web APIs, JDCP APIs, flat files, CSV, JSON, XML, and appscript services. You can see the architecture. We have your data, we have the data fetching, we have the community connector, and to Looker Studio. Now, we want to consider a scenario where we have published a package on NPM. So let's go to the NPM, and you want to track the down. So this is NPM. And remember, NPM and GitHub are sister companies. So you want to track the download count. So now this is the scenario we are considering. We have published a package on NPM and want to track the download count of the package over time by a day. So yeah, we're looking at download count. We're looking at count of packages over time by day. So if it's a year, it's 365 days. So if it's a week, it's 7 days. Now in this code lab, we'll build a community connector that fetches data using the npm package download count API. So let's open the link in new tab. You can see it here on GitHub. So download the package cancel. What I can do is can get a copy of this later when we end this code lab. Now, the community connector can then be used in Data Studio to build a dashboard to visualize download counts. So let's go to the next. Now, in the basic community connector, you will define four functions: get authorization type, the config, get schema, get data. Depending on the current step of the workflow, Data Studio executes these connector functions and uses the response in the subsequent steps. So if we go to Ask Gemini, here's a breakdown from Ask Gemini. So the get authorization type, what it does, it tells Looker Studio how users authenticate the external data source, as the APIs and database, why it matters. Before pulling any data, Looker Studio needs to know what credentials to request from the user. And we can see similar things like this on Tableau. So if I had come to the connect section on, I come to the connect section on Tableau, and I go to more, and I probably want to use the Google BigQuery. Once I click on it, I'm seeing the authorization. So that is part of what we're talking about here. Then get config, what it does, it defines the user configuration screen in Looker Studio. Why it matters is that this function lets you ask the user for parameters before connecting to the data. Get schema, what it does, it defines the structure and the data type of the fields our connector returns. Why it matters is that Looker Studio uses this schema to understand what piece of data represents, such as declaring whether a field is a dimension, text or date or a metric. Now get data. What it does, it fetches after data from our data source and returns it formatted for Looker Studio. Why it matters? This is where the main data pipeline runs. It receives a request specifying which fields Looker Studio needs for a report. So let us close this. So here's a video on how community connectors work. We won't be watching that, but here's the breakdown of what's on the video. Here we have the request to connector, we have Looker Studio user action at the beginning, and at the very end we have the get data and the show chat with data. So we'll go to the next section by clicking on the blue next button. Now we're going to set up our app script project. We'll visit Google App Script. Here's Google App Script. We will click on new project. We also click on new project. We will now see a shell with a blank my function page in the code.js file. So if you come here, I will click on new project. You'll see in this blank my function page. You can delete this, which is what we're required to do. And then we would put in a project name. So here I've put in a project name. And then in this area, we would copy the code.js file content. So let us click on next. So here's the code.js file. We copy it. We come here, Control A, delete, Control V, and we've pasted it in. So what we'll do next is here we are indicating that our connector does not require third-party authentication. So that's what we have here. Authentication type, none. So Data Studio would call the get authentication type function, and then the answer will be none. So to see all the supported authentication methods, we will look at the authentication type reference. Let us go to the authentication type reference for Google. Second. So these are the authentication type reference. We have the none, we have the authorization 2, we have key, user pass, user token, part user pass, part key. Now, what is this auth2? So auth2 is the industry standard protocol for authorization. Auth 2.0 focuses on client developer simplicity while providing specific authorization flows for web applications, desktop applications, mobile phones, and living room devices. This specification and its extensions are being developed with the IETF authorization working group. So Auth 2.1 is in progress with efforts to consolidate Auth 2.0 and many common extensions under a new name. So there's a video course on Udemy for Auth 2.0 simplified. That can be checked out another time. So we go back to our script. We've finished with this. We have seen all the authorization type references. We'll click on the blue next button. Now we're going to define our get config. Users of your connector will need to configure the connector before they can start using it. The get config function response defines the configuration options users will see. Data Studio calls the getConfig function to get the connector's configuration details based on the response provided by getConfig. Data Studio will render the connector configuration screen and change certain connector behavior. In the configuration screen, you can provide information or get user input using the following form elements. Text input is input element, a single line text box. Text area is input element, a multi-line text area box. Select single, a drop-down for single select options. Select multiple, a drop-down for multiple select options. Checkbox is input element, a single checkbox that can be used to capture Boolean values. Info, display element, a static plain text that can be used to provide instructions for information to the user. Use the info element to provide user instructions and a text input element to get the input package name from the user. In the getConfig response, you will group this form element under the config parameters key. Since the API you are connecting to requires date as a parameter, set date range required to true in the getConfig response. This tells Data Studio to provide the date ranges with all requests. If your data source does not require date as a parameter, you can omit this. Add the following getConfig code to your code.js file. Below is editing code for get authorization type. So let us copy this code. So now we would add this under our code.js. Let's come to enter. We now come to command V on line 11. Once we've done that, we'll come back to our instruction guide. So based on these parameters, when you use the connector in Data Studio, you can expect to see a configuration screen following, but more on that later. Let's move on to the next function, the get schema. We'll end this part and start the next section in a new video. Now we are on the next section of this code lab, section 8, where we'll define the get schema. Data Studio calls the get schema function to get the schema associated with the user selected configuration for the connector. Based on the response given by get schema, Data Studio will show the field screen to the user listing all the fields in the connector. For any specific configuration for your connector, the schema is a list of fields for which the connector can provide data. A connector might return a different schema with different fields based on various configurations. The schema can contain fields that you fetch from your API source, fields that calculate the API, the app script, and fields that are located or calculated in Data Studio using a calculated formula. The connector provides the metadata about each field in the schema, including the name of the field, the data type for the field, and schematic information. We'll review the get schema and field reference later to learn more. Depending on how your connector fetches, the schema may be fixed or dynamically calculated when get schema is called. Configuration parameters from get config that are defined by the user will be provided in the request argument for the get schema function. For this code lab, we do not need to access the request argument. We will learn more about the request argument when we write the article for get data function in the next segment. For our connector, the schema is fixed and contains the following three fields: package name, downloads, and day. So remember we had talked about this in the previous sections. So we mentioned the package name, we mentioned days, and we mentioned download count. Below is the get schema code for the connector. The get fields helper function abstracts out the creation of the fields since the functionality is needed by both get schema and get data. We'll add the following code to our code.js file. So we click on the copy. So once you click on the copy, or you hold down your left section and we copy, we hold down selection and copy, right click and copy in the mark. So once we copy, we go to our code.js, we hit enter. Now we are on line 27. We hit enter to go to the next line, and we hit command V to paste. So we have the code in. We go back to our code lab. So based on the schema, we can expect to see the following fields in Data Studio field screen when we use the connector in Data Studio, but more on that later when we test our connector. Now we're going to move to the next section, which is our last function, get data. We will click on the blue next button. Now, section 9. We'll define get data here, and this is the part 1 of it. Data Studio calls the get data function anytime it needs to fetch data. Based on the response provided by get data, Data Studio will render an update chart in the dashboard. Get data may be called during these events, and these are the events. User adds a chart to the dashboard, get data is called up. User edits a chart, get data is called up. User views the dashboard, get data is called up. User edits a filter or data controller associated, get data is called up. Data Studio needs a sample of data, get data is called up. There's no need to copy any code from this page since we'll copy the completed get data code in the later step. So now we're going to understand the request object. Data Studio uses the request object with each get data call. We'll read the structure of request object below, and this will help us understand the code for our get data function. So config parameters object, script parameters object, date range, start and end, like I mentioned before, fields name, field name in our parentheses. Now the config parameters object will contain configuration values for the parameters defined in the get config and configured by the user. The script parameters object will contain information relevant to connector execution. We do not need to use this for this code lab. The date range will contain the requested date range if requested in get config response. Field will contain the list of names of fields for which data is requested. For our connector, an example request from get data function will look like this. For the get data call in the above request, only two fields are being requested. And which are the two fields? Day and downloads. Even though the connector schema has additional fields, the next page will contain an example. So we're going to the next page. I click on next. Here's a note in green, highlighted in green. In this code lab, we are not using the request parameter for get schema. For get schema, the request parameter will contain only config parameters and script parameters. We'll go to the next section by clicking on the blue next button. Now we're going to define get data part 2. In the get data response, you will need to provide schema and data for the requested fields. You will divide up the code into 3 segments. Create schema for requested fields, fetch and pass data from API, transform pass data and filter for requested fields. There's no need to copy any code from this page since we will copy the completed get data in the next page. This is the structure of get data for our connector. So function is get data request, open parenthesis to do. So this has been commented. This is our commented, which is create schema for requested fields, fetch and pass data from API, transform pass data and filter for requested fields, return schema, filtered schema, rows, transform and filter data. Create schema for requested fields. Here it is, part of it has been commented. Variable requested field IDs is equal to request field IDs map function field. Now there's the fetch and pass data from API. The npm API URL will be in this format: API dot, which is here. So these are the different sections. Remember, we'll create the URL for the API using the request date range, start date, request date range, end date. Now, transform pass data and filter for requested fields. The response from the npm API will be in the following format: downloads 2014 February the 27th, download number, the day, the download number, start, end, package, name, same package. Now, transform the response from npm API and provide the get data response in the following format. If this format is unclear, have a look at the example response in the following paragraph. In the response, return the schema for only the requested fields using the schema property. You will return the data using the rows property as a list of rows. So you can see the rows property as a list of rows with values in front of them. We have already made the subset of schema. Use the following function to transform the path data and filter down the requested fields. So we can see how they are filtering down requested fields. To go to the next section, we click on the blue next button. Now, we're going to define get data part 3. The combined get data code will look like the one below. So add the following code to our code.js file. So we're going to click on this, copy to clipboard, and we're going to add it to our code.js file. So this is our code.js file. We go to the last line, Command V on the Mac, we've added it. So we go back to our code lab. So now he says we are done with the code.js file. Next, we'll update the manifest. In the appscript editor, we'll select project settings and show appscript.json manifest in the file editor. We'll go to select project settings and see it here. Once we take our hand to the left, a flyout has come out with project setting as the last item under. We'll click on it. There's a pop-up message that says save pending script changes. So we'll click on save because we have not made some changes to the scripts that we had earlier. So under the project settings, let us read the instructions. We're going to select show app script manifest in the editor. So go there, we'll select it. Next thing we will do, note that this will create a new appscript.json manifest file. So we're going to replace our AppScript JSON file with the following. So we copy this content, we come here. So by the time we come back to our editor, you can see our AppScript JSON file at the upper left. So we'll click on it. So you can see just has a time zone and exception logging. So select everything here and hit delete or backspace, command V to paste what we copied here. Now we're going to save the AppScript project. So save the project to drive, replace to save the project. Say command S. So command S is saving it. So we've saved it. So the next thing we're to do, so here we're being convoluted that we're built our first community connector and is ready for a test drive. So to test our connector in Data Studio, we'll use the deployment. Step 1, in the AppScript development environment, we'll click on deploy and we'll go to test deployments to open the test deployments dialog. We'll click on deploy, come down to test deployment. So on the test deployment dialog, the default deployment head deployment will be listed. So if you come here, default is head deployment, you can see it here. So what we'll do, we'll click copy, copy to the head deployment ID. So we'll click on this. Next, what we'll do is to load our connector in Data Studio, we'll replace the head deployment ID placeholder in the following link with our connector's head deployment ID and follow the link in our browser. So what we do first is we open a new tab, we copy the URL, command V. Then for this in the bracket, we will delete. Then we come here to where we copied it before, and then we paste it, command V, and we hit enter to take us to local studio. Sorry, I meant data studio. So we have gotten here. The local studio is now called data studio. We can see it here. So let us dismiss this. So it has seen our npm from CodeLab by the CodeLab user. So we're now going to authorize the connector. So let us go and click on authorize to authorize the connector. So Google hasn't verified this app. This app is requesting access. Until the developer verifies it, you shouldn't use it. So just advanced. And say continue only if you understand the risks. So we continue, we understand the risks. Then we'll now click on go to the business intelligence Saturday. So we're having another message that this app hasn't been verified, but because we created it, we know because it's asking for access to our part of our Google account. So we click on continue because we created it. They want us to complete our authorization. So So we've completed our authorization. Then next we're going to click on connect to continue. To connect is at the upper right blue box. So now we're going to now get a preview to confirm our schema. So what we want are the fields, which are the dimensions for day downloads and day downloads and package name. They are the three dimensions we're seeing here to the left in green. So what we'll now do, we'll now click on create report. So we're about to add data to this report. So we can just now say add to report. So we can see our fields here on the right. So now we can add a timeline series. We'll click insert and click on time series. So we'll do that in the next video. So now we are going to work on creating our first time series on Data Studio. Remember, we started it from here. We're going to create our time series. We'll click insert and then we'll click on time series. So insert and click on time series chart. Then it will follow our mouse pointer, and where we drop it, the time series chart starts to initialize. So we have our day, we have our downloads, our data source, we have our X dimensions, we have our Y dimensions. So that is it. We just created our first community connector. This brings us to the end of the code lab. Let's see what next steps we can take. We click on the blue next box. The next steps, we improve the connector we built. We'll make improvements to the connector we just built. And also remember, once you get to the end of a code lab, you get the badge for learning that code lab. So make improvements to our connector we just built. In Data Studio, if you do not provide a package name in the configuration screen for a connector, you see an error message. So let's go back and see add a package name. So we have a package name here, which is the npm downloads. You can also add other fields from here. You can add calculated field, you can add a parameter. We can filter by email. So you can see our data freshness here is 12 hours. You can see community visualization access is on. So you can also see here for improvement, we can try adding support for querying multiple packages names at the same time in our connector config. The hint is the npm package download API. So we can look at the npm package download API. So we had looked at this earlier. Then remember it supports input of multiple package names separated by the comma. You can find solutions to both of these in our npm connector code. You can look at this in npm connector code on GitHub. You can see it's not an official Google product. Then here is the part for additional resources. So remember, we can do more with community connectors. We can view the reference for the connector API, which we have seen. We can explore the example connector code in open source repository to understand the best practices. So these are community connectors. You can look at them to understand best practices. You can complete the CLAPS code lab. So there's another code lab where we can develop community connectors in our local environment. Also, once you have built a complete community connector, considering the publishing options available, look at that. You can build a community visualization for Data Studio. So here are additional resources. So here are some various resources that can access to help us to dig into material covered in this code lab the more. We have resource types, documentations, news and updates, ask questions, videos, examples, help center. For user features, we have help center, sign up, we have user forum, we have database dev talk, we have report gallery, we have connector gallery. For developer features, we have developer documentation, we have developer mailing list, we have Stack Overflow, Looker Studio is a topic, and we have open source repository. So this is the end of the video. So welcome to the end of this video, and see you in another video. Thank you.